We already had a histogram turned on from last time with group data. It was the Portland Marathon data. No, it was your text message data is what it was, text message data. But regardless, we put the text message data in the same way we did this. So we had beautiful strings of data and frequencies. So if you press zoom 9, there's our distribution, what it looks like. If you had to describe that data, how would you describe it?
Looks squishy.
Skewed? Squishy? I like squishy, skewed. Would anybody call it bell-shaped?
No.
I don't think it's bell-shaped. Now, you can finagle. And I like doing this personally. I like finagle in the graph. Whenever you press zoom 9, the TI is always going to put 7 categories down. Always. It's just by default, it slaps 7 bars up. You can make it do other numbers of bars if you want to. So for example, the first thing I did was I went to the Windows screen. And I went to Xmin and Xmax. I saw it was at 5 and 31, and that seemed like a strange bunch of numbers. So I changed 31 to 30, and I changed X scale instead of 3 and 5/6, I think is what it is right now. I just changed it to 5. What this will do is it'll lay down, boom, 5 bars. Now I just press graph at that point. Yeah, just press graph. Now this might be too few bars for your liking. Because now you've got 5, which is fewer than 7. What I'm looking for is I'm trying to see if there's a bell curve hiding in there anywhere. This looks slightly more like a bell curve. I say slightly, but the problem I have with it is that middle drop. Almost as if it's got 2 modes and I'm missing them both. So I think now, I kind of don't like 5 bars. I want to double it to 10 bars. What will I have to change X scale to do that? Remember, X scale, you forgot this since Wednesday, totally fine. X scale is how wide each bar is. So when I type X scale is 5 and I press trace, this goes from 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30. So what would I have to change X scale to be in order to get twice as many bars? Careful, 2.5.
Yeah.
If I make it 10, watch what happens. If I make it 10,
You get 3.
I get half as many bars because I made them twice as wide. Does that make sense?
Yes.
To get twice as many bars, I got to change 2.5. There. So the more I finagle,
That's better.
the more I'm fairly convinced that this data is pretty skewed and pretty freaking interesting too. I mean, I've got like this cluster here, kind of a cool cluster here, definitely a cool cluster over here. I've got like micro clusters along the entire way. Now, I'm not saying I might use this, but what was the average number of states we've been to?
16.
16 on average. On average, we got 16 states. Oh, real quick review. Remember how to get this. Stat, calc, 1 bar. Just make sure you tell it L1, L2.
Oh, right.
Because if you don't, it's going to give you an answer that's wrong. It's going to ignore the frequencies if you don't do that. So L1, L2. Yeah, comma's right above 7.
Okay.
Make sure you give it the frequencies, otherwise it assumes one student's been to 5, 1 to 6, 1 to 7, 1 to 10, and so forth. Boom.
Okay, that's for the 83 though, right? The 84.
84 is exactly the same. Well, you guys, you and Stacy have your setup a little bit different. You just put L1 and L2 in for, what is it, X list and freak?
Yeah, it's list of
Yeah,
frequency.
just same thing.
Yeah.
You do the same thing, but in a different syntax, yeah. Cool?
Yes.
So there's our average of 16 states. Now the problem with an average of 16 states that I have is kind of this. There's 16 right there. I think it does kind of a strange job of describing on average what's going on. Only 1 student has been there. And even if you bump it out, standard deviations, which is 7, right? Plus or minus 7 states. Even if you bump out standard deviations, as you move away from that 16, you're picking up some data for sure, Christina.
Well, but that's because it's bimodal and there's that drop in the center.
Yeah,
so
that's the problem.
average.
Well, so what you're doing is you're over-representing the data set because of the high numbers down here, these outliers, if you will, that are happening down here, pulling the average to the right. So since the average is being pulled to the right, the standard deviation is also going to be kind of skewed. So in my opinion, this is the kind of thing I would ask you to give me these values, and on an out-of-class assessment, I'd say, would you even use them? And my response is, I wouldn't. I wouldn't because they could potentially overrepresent a data set. Go, Madeline.
So, I mean, you're calling 28 an outlier, but it's also one of the two modes.
Yes!
So, like, how do you call that an outlier?
Hold that thought. Just hold that thought. You're getting into why we're talking about this.
Okay.
Because what happens when, I've actually seen a data set that's 44% outliers by the standard definitions. I know, weird. And there's ways to quantify outliers. We're getting to it, I promise. But just give me some time, I love it. Go down and get the median. There's your median. 13 states makes a little more sense. There's your geographic middle down here.
Oh, there we go.
Yep. What was your mode? Madeline gave us one of them. We have two. 13 and 28. Isn't that wild? So the question becomes, how do you deal with this data set that is so
Funky.
funky? Is a great word. It's definitely a funky data set. How do you deal with a data set where all three measures kind of disagree with each other? And the answer, one answer, I shouldn't say the answer, I'm going to take that back. It's not the answer. An answer is you can talk about it a different way. You don't have to talk about a data set with respect to center all the time. With Max's weights, did we even talk about his average weight? The average weight of a 2-year-old white American male? We never did. We never mentioned it. We talked about percentage, exclusion, above and below a certain percentage. And that's why measures of center are fantastic, but they are not the be-all and end-all. There's also something, and we'll start this today, we're not going to get very far into it, and it's totally fine. I want to give you a quick overview. We'll come back to our state data on Wednesday after your guys' exam. The in-class part of your exam will not take you the entire class to knock out. I'm thinking you guys will be done within 45 minutes to an hour. And then we'll wrap this state discussion up then. I want to talk about other ways to measure data. Here's an overview for us to take with us next time. They're called measures of relative position. Put a box around that, why not? Relative position. What do I mean when I say relative position? Well, what does the word relative mean from before? Relative frequency. Remember that? Relative frequency? Was another fancy word for what?
Counting, I don't,
In relation to.
Say that again, Tiff.
think counting, really.
Yeah?
Counting
Hold
how
that
many
thought down.
times?
Good. How many times? And then we express it as a percentage.
Yeah.
So if you have 100 data points, and 32 of them are between two values, that's 32% of the data set. If you have 50 data points and 16 of them are in a certain, that's still 32% of the data set. It's in relation to the other elements of the data set. That's what the relative position means. It's talking about the positions of data points, or the divisions of data, relative to the other members of the data set. This is different than an average and a standard deviation, which are absolute measures. The average is this. It's this, and it's for all 100. The standard deviation, therefore, is this, and it's that for all 100. Relative position simply takes the data point or data points you're interested in and says, okay, how do they compare to the other ones? As a percentage. As a percentage. And we're going to use percentages most exclusively. We already talked about one. You already have one measure. Percentile. Percentile is your first. I'll put a little checkbox next to that. We talked about him. What I want to do next time is dive into one other kind. And once you understand the other kind, any of the other types that are out there, I mentioned the quintile earlier today, and Danny said, wait, did you mean quartile? They're all used. Deciles, quartiles, quintiles, octals, they're all used. And we're going to talk about quartiles next time for sure. John, go. You sure?
I was just going to say, couldn't you just divide it in half? Split that data set down the middle?
That is a percentile as well as a quartile. It's the 50th percentile, also known as the second quartile, which is also known as the median. Yes, exactly. The question is, how do you split it? Do you split it with an average? Do you split it geographically? This is all going to be geographic location relative. So that's what relative position is tied to the median, in that you take the data, spread it out, and then analyze it left to right, smallest to biggest, or biggest to smallest, depending on which way you want to go. But we're not going to be able to do that in 2 minutes. So let's stop for today. Yes? Yes, we'll stop for today. Yes! Bring your state data back. I'm going to store that I'm gonna store it to list L5 and L6, but you guys make sure you bring it back too. I don't wanna lose this. Any questions about the exams, guys? Just shoot me emails. Yeah, that's it. Go study hard. Send me emails if you get stuck. Otherwise, we'll catch you on Wednesday. Kick some butt. You're not nervous, are you? Ish? How's your anxiety level now compared to when you walked in here?
Pretty good.
Decent? You also have an advantage too. You've seen my exams before, so you kind of know what they're all about.
Well, kind of, but you always say, it won't take an hour, and it